everyone, welcome back. In this particular video, we will be discussing the problem search in a sorted rotated array. Is an array which is sorted in ascending order, but now the point is it is not only sorted in increasing order, it is rotated about a pivot which is unknown to you. It was used to be sorted array, but after being the array to be in increasing order, it was rotated in the form of some clockwise rotations, or you can say there was a pivot index on which the array was rotated. Now such a array is referred as a rotated sorted array or sorted pivoted array. Both are one and the same thing. Sorted array but rotated in nature, not completely sorted after rotation, obviously. Example is, if let's say the array used to be 1 2 3 4 5 before rotation, after rotation I picked the smaller value and actually I picked the value 4 and I rotated it up along 4, or actually not around 4, around 3. That is, I made the 3 element, 4 element, 5 element go in the front. That is 3 4 5 1 2 is what the array is after the rotation. What you need to do is, in such array which is a rotated sorted array, you have to get a target value, get some integer value and check whether the integer value is present or not. Return the index in which it is stored in zero-based indexing. Otherwise, if it is not found, then return -1. So let's take the example of 3 4 5 1 2 itself. Since this array is rotated sorted, if I ask you that what is the index of the target, maybe 2, so you will say it is at present at the 4th index. What is the target where 4 is present? You will say first index. What is the target index of 6? There is no 6 present in this array. So return -1. So I think the problem is clear. You can also see the sample input. Sample input is containing 4, 5, 6, 9, 10, and then 2, 3. So rotated sorted array 2, 3, 4, 5, 6, 9, 10. So it was used to be sorted, but now rotated. If the target is 2, 2 is present at the 6th index. If the target is, you can say 3, then 3 is present at which index? 3 is actually present at, there is some problem. Actually, this is the second test case. This is the first test case. And this is the other test case, something like that. Or maybe it might be something else. Let's see what is the input format. The input format is that first, there will be q plus 3 lines of code. First line will be the size of array. Then the next line will contain n integers, which is the array elements. Third line will contain a single integer q denoting the number of targets. Okay. So basically it is the number of test cases. So there are 2 test cases. First test case is 3. 3 is present at the 6th index. So 6 is the answer. Then next test case is 8. 8 is present in the array. No, since it is not present, print -1. So I have taken an array already in my notes. Using this array, we will try to deduce the approaches. First of all, if let's say the target given to you is the value maybe 80, you need to check where is 80 present. I will say it is present at the 3rd index. You have to return 3. However, if the target is, let's say, maybe 25, in that case, you will say -1 because 25 is not present. So in this case, answer should be 3. In this case, answer should be -1. But the point is, how will you figure out it? One of the easiest approach, which surely most of you will be able to figure out, is the linear search algorithm, in which you will just simply run a loop over all the elements, irrespective of whether array is sorted, rotated, whatever. We just run a loop over all the elements one by one and check whether it is present or not, irrespective of the ordering of elements. Linear search will always work. So to just run a linear search, that is a linear traversal over an array of n size, it will take linear time, although the space will be constant. That is no extra space required. But is it the most optimized solution? Surely not. Why? Because we have not used the fact that array is rotated sorted array. So if we have to use rotated sorted array, one optimization over linear search, which usually works on sorted arrays, are binary search algorithms. But binary search algorithm in this case cannot work directly. Why it cannot work directly? The point is the array is not completely sorted. It used to be sorted, but now it is rotated. So since you know you can apply a binary search on a sorted array, you know how to apply it. I am assuming it is a prerequisite for this question. But you don't know how to apply it in a rotated sorted array. So how about first figuring out where is the array rotated at, or what is the pivot index? Once we know the pivot index, then we can just apply the binary search around that pivot. That is, given this array which is having the range from 50, 60, 70, 80, 90, 100, 110 increasing, and then there is a dip, and then from 10 till 40 it is again increasing. So in such a kind of array, what we can do is we can just figure out this pivot index where the array was rotated. That is, these are two segments of the array. First segment will be from 50 to 110. Second segment will be 10 till 40, because array, if it would have been sorted, how would that it would look like? 10, 20, 30, 40, then 40, 50, 60, 70, 80, up till 110. So rotated sorted array. So just figure out the 2 points on which the array is rotated. Just figure out this pivot. This is the pivot where array is rotated. You can just figure out the pivot in terms of 6th index or 7th index in this example. Once you are able to figure out the pivot index, what you can do is you can apply the binary search in the left part of the pivot and in the right part of the pivot. And you know already how to apply binary search. It is just the range of the binary search will change. Instead of binary search simply on 0 till n minus 1, it will be from 0 till pivot and pivot plus 1 till n minus 1. But the point is how we can find this pivot index, that is the 6th index. Let's say we are figuring out the 6th index, that is the last index of the first segment, or you can say the index previous to the first element of the second segment. So how can you figure out the 6? Any special value which is present at the 6th index? And the answer is yes. If you will see that these values are 10, 20, 30, 40, this used to be in the left hand side if array was not rotated. So all these values are smaller than all of these values. The second part, if I say this is the second part, this is the first part, all of the values are second in the second part are smaller than the values in first part. And how about if I say that among the first part, the values are increasing order, it means 110 is more than all these values. Since first part is in increasing order, it means 110 is more than all these values. Since second part is also in increasing order and second part used to be before first part, before rotation, all these values are smaller than first part. It means the element present at 6th index, which is 110, is actually the maximum element. It is also pretty obvious to observe that actually 6th index is the maximum element and 7th index is the minimum element. This is the max, this is the min. So you can just easily figure out max or min, but that too not using a simple linear search. Otherwise, you are just having same time complexity. You have to figure out the maximum value or the minimum value using binary search itself. And the point is, how will you figure out the maximum or the minimum using binary search? So for that, let's pick this array on the next page. Let's copy this array on the next page and let's try to first do the binary search to find the maximum index, not the value, but the index. So I am finding max index, something like this. That is 6th index in this case. So we have to actually work on the same observation, that is all these values in the left segment are smaller than 110. All these values are greater than 110. But there is one more observation which we can make. What is that observation? But just mark these two segments again. This is the first segment, which is, I am saying, is the rotated segment, or actually both are rotated only. The entire array is rotated. Let's just say it is the first segment. And this is the second segment. Any bifurcation which you can do, any distinguishing factor between the first segment and second segment, which you can figure out so that you can apply binary search. Because in binary search, normal binary search will work on a target. The question is to find out a target only, but right now the focus is not to find the target, but to first find the pivot. If we know the pivot, we can easily apply binary search to find the target also. So in order to find pivot, we don't know where the pivot will be. We don't know where the maximum element or the minimum element will be. That is the question itself right now. So observation is, if let's say we land on some mid value, we are initially having left pointer at 0. We are initially having right pointer at the array dot length -1, because we don't know where the minimum element or the maximum element will be. We are just finding maximum. Mid will come out to be 0 plus 10 by 2, which is the 5th index. Now what to do with this 5th index? You don't know actually where the maximum will be with respect to 100. Why? Because if you will ask to the mid index, the array is in increasing order right now. From 4 to 5 to 6, values are 90, 100, 110. So it is increasing in nature. Even if the mid was, let's say, at the 9th index or let's say at the 8th index, still the array will be increasing. Why? Because 8th index is having value 20, 9th index is having value 30, 4th and the 10th index is having value 40. So it is still increasing in nature. So you can't just simply say that in this particular segment, value is decreasing in nature, in this particular segment, value is increasing in nature. No, in both the regions, values are increasing. It is also increasing slope. This is also increasing slope. Just the point is, pivot will have decreasing slope, but that is the question itself, how to find pivot. But there is a very beautiful observation which we can make apart from the pivot being having a dip, having a decreasing slope. That observation is all of these values which are in the second segment are smaller than this particular segment. And since all of these values are smaller than the first segment, they will be smaller than the smallest element in the first segment, which is 50. So I will say all the second segment's values will be smaller than array of 0, which is 50 in this case. And all the values in the first segment, in this segment, will be more than or equal to 50. It will be more than or equal to array of 0. So this is how we are distinguishing between the first segment and second segment. That is, if certain value lies in the second segment, then that value will be less than array of 0. If certain value lies in the first segment, that value will be greater than equal to array of 0. So right now the mid was what? Mid was 100. Since mid was 100, it is more than equal to 50. It means it is lying in the first segment. Since 100 is more than equal to 50, it lies in the first segment. Where should we go from first segment? We want to figure out the last element of the first segment. So we should go to the right side. Then only we will go to the last element of that first segment. That is the first part. So go to the right side by doing what? By updating left as mid plus 1. Figuring out the new mid, 6 plus 10 by 2, which is coming out to be 8th index. That is 16 by 2. As to the 20 value, is it lying in the second segment or first segment? Is it less than array of 0 or more than equal to array of 0? You can say 20 is less than 50. Since 20 is less than 50, it lies in the other segment, which is the second segment. And when you are standing on a second segment, where you can figure out the maximum value? On the left hand side, because maximum value will be in the first segment, which is in the left hand side. So go to the left. So go to the left means update right pointer as mid minus 1. Check out the new mid. Left plus right by 2, which is 6 plus 7 by 2, which is 6th index. Again ask, is the 6th index value lying in the first segment or second segment? You will say 110 is more than equal to 50. So it lies in the first segment. First segment means you will go to the right side. Although what you can do is, whenever you are reaching on an element, the mid index is reaching to such an element which is lies in the first segment, you can update the answer. Initially answer can be made -1 or maybe the value 50. You can initialize it with anything, that is array of 0. Then you will say, since mid was coming out to be first at 100, 100 was better answer because it is better maximum. 110 is even better maximum right now, the current mid. Every time just update the answer with the maximum values. You will still continue the binary search, that is go to the right side, because on a first segment value, you will still search for the maximum value going to the right side. But if you will do left as mid plus 1, you will figure out the new mid. The new mid will come out to be 7th index, which is value 10. And if it is value 10, you will say 10 is not more than 110. So don't update the answer. But since you are lying on the second segment, go to the left hand side. If you will go to the left hand side where you will reach, you will say right will become mid minus 1. And as soon as it is done, left and right pointers have crossed each other. Left is at the 7th index, right is at the 6th index. So if you don't want to maintain the answer, you can also do what? You can just return the right index because that is a maximum value. But answer maintaining will be easier because it will always give you that value. Actually, you don't need value, you only need index. So first, it will not be 50, it will be 0th index. Then it will become the 5th index. And then it will become the 6th index value. That is, you just need to return index where the maximum is. And as soon as you are able to figure out that index where the maximum lies, now you know the two segments. You know first segment is from 0 till the answer, 0 till the pivot. Answer is nothing but pivot with 0 till 6. And you know the second segment also, which is pivot plus 1 till n minus 1. So apply binary search first in this segment, 0 till pivot, and then in this segment to search whatever the target is. If target is present in the first segment, just return wherever it is present. If it is present in the second segment, return wherever it is present. Maybe if target was 30, return 9. If target was 80, return 3. However, if target is like 25, which is neither present in the first segment nor present in the second segment, then return -1. So apply binary search in total 3 times. First time to figure out the pivot index. This is the logic to figure out pivot. Then to figure out the target in the left range, that is first range, and then to figure out the pivot, actually the target in the second segment, that is after the pivot. So this is the approach which will take only logarithmic time because we are just applying 3 times binary search. So it can be worst case 3 log n only, which is still logarithmic. And the space complexity will not be as such because we are not taking any extra data structure. Binary search is just an algorithm without extra space. Lean logarithmic time and constant space solution, which is the optimized solution. We will write the instruction manual now corresponding to this approach. So let's do what? First step will be to find out the pivot. So for that, I am making a function which will return the pivot index. I'm naming the function as find pivot or find max index, whatever the function name you want to give. You will pass the array, but although in this function, you don't need to give the target because we are not searching for target right now. We are just figuring out where the maximum element is present so that we can apply binary search to find target using that pivot index. That is from 0 till pivot and then pivot +1 till last index. So in order to figure out pivot, we are initializing the answer. We are setting the answer as what? As initially 0. We can assume the minimum is present at the 0th index itself. Why to just consider it at any other index? It can be that array is not sorted at all or not rotated at all. If array is not rotated at all, although the maximum will remain at the last index, but we can initialize it with the 0th index also. It is actually your wish. Each step, what we need to do every time, we need to run a loop till the point left pointer is smaller than or equal to right pointer, and left will set as initially 0, left is equals to 0, right is equal to initially n minus 1, where is n is array length. It is self-explanatory. Run the while loop till that left pointer is either smaller or equal to the right pointer. What we need to do in each step, we need to just say that is the current mid index. First figure out the mid index, which is nothing but average of left and right, the middle value. Is it lying in the first range or second range? And what was the comparison? The comparison was with array of 0. Whether the array of mid is less than array of 0 or it is more than equal to array of 0. If it is less than array of 0, do something else. Otherwise, if it is more than array of 0, do something else. First of all, if it is less than array of 0, what was the segment? It was a second segment, and second segment is not what the answer we want. We don't want the minimums. We want the maximum. So we don't update the answer. However, we will update right pointer and make it mid -1. That is go towards the left side. So we will say in this if condition, if it is yes, then update the right pointer as mid -1. However, in the else case, do two things. First, update the answer as the current index and also update the left pointer as mid +1 because we have to go towards the right side. If we are in the first range, go towards the right side to find out the maximum. So finally, once you are having the answer, just return that answer because that is the pivot index. Return answer. This is the first step. But now we need one more function which will actually do the binary search in a particular range. So I will say I will have a function which will find or search a particular element, but not in the entire array. That is, I will give the array, I will pass the target which we need to search, but along with this, I will pass the range in which I want to search. I will pass both the left as well as right pointers because sometimes it will be 0 till 6, sometimes it will be 7 till 10, sometimes it will be 0 till pivot, sometimes it will be pivot +1 till n-1. Now the binary search is a simple binary search. Simple binary search means run the loop till left is smaller than or equal to right. You already have the left and right pointer in the parameter. No need to declare them again. Just set the mid as left plus right by 2. And this time just compare the mid index with target itself. If array of mid is equal to target, do something. However, if it is, let's say, we can say in the second scenario, it can be else if array of mid is less than target, do something else. Or if it is greater than target, then of course do something else. What we should do in the case of array of mid is equal to target found, return the mid index because we need to find mid index where is the target present, what is the index of that. If target is greater, so it will be found in the right hand side, that is left will become mid plus 1. However, if target is smaller in value, it will be found in the left, that is make the right become mid minus 1. This is a simple binary search, nothing to explain in this, just the point was the finding pivot index. So first in the actual function, what you need to do, first find the pivot. So find pivot by calling function find pivot, by calling find pivot function. Now whatever find pivot will give you, first check in the first range. If the first range will not give you -1, actually after the loop you have to return -1, the target was not found. So if the target is present in the first range, it will not give you a non-negative value, it will give you a positive value or zero value. So if the search in the range 0 till pivot will give you non-negative value, will be non-negative, then what we need to do, return that value, return that answer. However, if the first range is giving you -1, then whatever second range will give you, just assume that as the answer, because if both ranges will give -1, then -1 remain the answer. If first range is giving -1, it means the target is not present in the first range, then surely it will be present in the second range. If target is not present in first range, then it will be present in second range only, or it will be not present at all. So just return, otherwise that search in the range pivot +1 till n-1, where again n is the array's length. So quite a lot bit of code. However, time complexity even after a lot of code will be logarithmic. Space will be constant because we are just doing binary search 3 times in total. In the code for the problem, search in a rotated sorted array. We have already written the instruction manual, which are using 3 times binary search algorithm, first to figure out mid and then to actually search. So we are using the binary search in order to implement the question. Using the pseudocode, using this instruction manual, we will write code in Java programming language specifically. So let's just directly jump onto the code part. First point is we need to first find the pivot by just calling the function pivot. I'm not implementing the pivot right now. I already know the function name, which is find pivot. What I will pass is the array which we need to find pivot in, that is a maximum index. Whatever the maximum index is, just first find the answer in the left range. That is, search the target in the array from left till right, and left will be 0, right will be pivot minus pivot only, not pivot -1, but pivot. If the target is present in this range, then well and good. That is, if this answer is not -1, then this itself is the answer. So return that answer. This is what it is mentioned here. Let me just write it above it. However, if left range does not give you the answer, then surely right range will give you the answer. So in the other scenario, just search for the other range. That is what we have discussed in the approach part also. Nothing to explain again. And you can say that n is nums.length. That is number of elements. So what we need to do, first of all, in the find pivot function, we have to find the index where the maximum element resides. For that, we are checking whether the mid index is smaller than array of 0 or it is greater than array of 0. Whatever the case is, we are updating the answer in the second scenario. So we will say initially the answer is 0. We will have the range starting from 0 till n-1 because this binary search will work on the entire array itself. However, the binary search will work till the point left is smaller than or equal to right. Every time what we need to do, we need to just check whether the mid index is smaller than array of 0 or greater than array of 0. So first figure out the mid index. So mid index will be the average of left and right. Check this mid index whether it is having value smaller than array of 0. If yes, then just do what? Then just do updation of right pointer, which is going to become mid -1. However, in the other scenario, it is quite opposite to that. If it is in the other range, then do what? Sorry. In the other range, first update the answer and also update the left pointer and make it mid +1. And finally return the answer. So let's just for now print what the mid index is giving you in the case of the first find pivot index. For now, just return -1 here. I'm just saying, let's just print whatever the pivot is going to give us. System.out.println pivot. Let's just see whether it is working fine or not. Then the other function is just a simple binary search. It is taking some time to run. Hopefully it should be correct for this array. If this is the array, actually there is some compilation error. What is the compilation error? Array name is nums and I'm using ARR. So let's do everywhere ARR only. If we are just comparing with ARR. Let's run it again and see. So as you can see, the pivot index for this array is at the fourth index. That is the maximum value 0, 1, 2, 3. And you are actually getting 4. So something is wrong. 0, 1, 2, 3, fourth index we are getting. Although we need the third index because third index is having the higher value. So actually this is not the output which we are getting. The actual output is what we are getting. We are actually getting third index only. So I was wrong here. Actually, the code is correct, at least for the find pivot. So you can take a screenshot for the find pivot function where we are actually just figuring out the pivot index, which is the maximum element index. Once we know the maximum element index, we can now search in the two ranges. First in the range from 0 till pivot, and then in the range from pivot plus 1 till mid minus 1, or actually n minus 1. So we will just apply a simple binary search that you already know. I'm just quickly coding this. I will first do what? First find out the mid. I already know the left and right as parameters. Just check whether array of mid is equal to target. If it is equal, return the mid index. Otherwise, if array of mid is smaller than target, then do the left as mid plus 1. However, if it is otherwise, then just do right as mid minus 1. So simple binary search. Let's just run it and see to confirm whether our code is working fine or not. Then we will actually end the video. So first it is again showing some errors because array name is not nums, it is error. Let's just change the array name and again run it. Hopefully it should be correct now. Although the output which we are getting is wrong, the point is we are not supposed to print pivot. We are only supposed to print whether target is present at some index, otherwise -1. So right now, as you can see, it is working as expected. Let's just submit, and already you can see all the test cases are passing. So this is the code. First find the pivot index, then do the search algorithm on the two ranges, and overall time complexity will be logarithmic, overall space complexity will be constant. That is a problem, and we will discuss a new problem in a new video. Till then, bye bye.